let's move on to polar coordinates. Suppose I have a point, and instead of xy, I want to talk about it in terms of its distance r from the origin and an angle measured from the positive x-axis. That positive x-axis we're going to call the polar axis, and r is a distance from the origin to our point. Now, we always measure our angle counterclockwise. Clocks are negative. So if you're going clockwise, you have a negative angle. Write that out. Now, I can take any point and represent it on what we're going to call a polar graph. So suppose I have the point 2 pi over 3. R is 2, and the angle is pi over 3. So each of these circles represents an R unit, like this is R1, R2, R3. So if I want to graph 2 pi over 3, the first thing I'm going to do is come and I'm going to measure and find the angle, pi over 3, and I'm going to draw that line, and then I'm going to go out along that line 1, 2 points. So this right here, this point right here represents 2 pi over 3. If I want to represent 3 negative pi over 6, all right, now clocks are negative, so I'm going to go backwards. So I'm going to go clockwise, pi over 6. So this angle right here is pi over 6. And then I'm going to go out 3 units. 1, 2, 3. Now, this is kind of interesting. Well, let me do this one first. Suppose I want 11 pi over 6. Well, I'm going to come over 11 pi over 6, which is all the way this way. And you'll see that this is the same angle as negative pi over 6. And then I'm going to come out 1, 2, 3 points. So you see, these aren't unique. I could have a negative angle, and that gives me the same point as a positive angle. It is also possible I could go backwards. So if I had wanted negative 3, 11 pi over 6, I would go out to 11 pi over 6 and then go back 3, 1, 2, 3. So this, if I could find it, would be a negative. All right, a negative radius. So I can put the dotted line there. Now, polar coordinates aren't unique, as we just saw. The angle can change by 2n pi, or we can have a radius that goes negative.